We'll just give people a few minutes to join in online. If you've just joined us, we're just waiting for a few people to join online. You can see there's some attendees popping in. Right, I think we'll get started. So thank you for joining us and welcome to today's webinar. My name is Alison Renwick. We're running the SoftTech webinar series to help our customers grow their business. We'd like our webinars to be interactive, so at any time during the webinar, if you have any questions, please type these in on the go to webinar questions block. And we have a Q&A session at the end of our presentation where we'll answer as many of these as we can. Perez joins us today as our speaker, and he'll be talking through BIM and trends in the construction industry. Brett has recently joined SoftTech as our strategic account manager in the APAC region. Along with the background in engineering and construction, as well as BIM or building information modeling, Brett's career achievements include guest lecturing at RMIT on technology in the construction industry. And he's also been invited to be a keynote speaker at the Australian Mechanical Contractors Association as well. So thanks again for joining us, and I'll hand over to Brett and he can begin our presentation.
Thanks, Alison. Welcome, everybody. So I will just run through our presentation, and if there are any questions, like Alison said, just please pop them in the questions bar. And I'll answer them at the end, and I'll begin the presentation. So building information modeling, or BIM, is what I'm here to talk about today, and trends in the construction industry. Really, to keep it more relative to the audience, I'm going to sort of go on a journey of the path that I've taken around construction in a practical sense as well. It's not going to be too high level. It'll be about how BIM is actually helping the construction industry in design and install and maintain. So giving some real life examples. So about SoftTech. So we're a company that we design, estimate and manufacture. It's premium software for the window and doors industry. So SoftTech has more than 10,000 window and door manufacturers, dealers and suppliers. They trust SoftTech to provide fast and accurate design, estimation and manufacturing solutions. It was founded back in 1988, and SoftTech is now a global company having offices in North America, Australia, New Zealand, UK, France, Turkey and India. We've had over 30 years experience in the door and window industry, software industry. We have developed a reputation of excellence and delivering some of the largest complex software solutions from some of the world's best industry leaders. And there's just a snapshot of the locations of our offices globally. So a little bit about myself. I've got over 20 years experience in the engineering and construction industry. I've implemented building information modeling workflows and design to fabrication processes, both in the engineering consulting world and in the construction world. Prior to joining SoftTech, I worked for a company called Autodesk, which I resolved business challenges with technology. So Autodesk is the maker of AutoCAD and Revit, which you may have already used or are thinking about using. In my current role as strategic account manager, I'll be working with companies to develop a firm understanding of their business processes, needs, and technical requirements. And in my spare time, I enjoy mountain biking, fishing, and camping with my wife and 3 kids. So also a bit of background on my project experience and where it all started, where I started to think about processes being a little bit static and broken was 2 projects. One was the Swiss Re building, or the Gherkin building in London, a Norman Foster project. He used that's the building on the left, looks like a gherkin. He used quite a complex program called Digital Project, and we still used a 2D CAD package to do our coordination. And then along to Wembley Stadium, which should have used building information modelling, and if they did, they wouldn't have had a blowout of about £250 million. So that project, I was on that for 3 years, and due to serious lack of information passing between services and contractors, it led to quite a disastrous project. And this is where I started to think about new technology to solve problems that shouldn't really be problems. The first real big BIM project I worked on was Margaret Court Arena, which is the fastest operable roof in the world. It opens and closes within 30 minutes. This is a medical facility in the University of Technology, Sydney, with PC3 and PC4 labs, and then the Darling Harbour International Convention Centre of Darling Harbour, which was one of the first projects where we used end-to-end BIM. And the last project that I worked on, which is very complicated, is the Dr. Chow Chak building in another UTS project, which is in Sydney. It's an amazing building designed by Frank Gehry, and it's fair to say probably wouldn't have been able to be built without the use of building information modelling. It was not a straight wall or a straight window in the entire project, and Frank Gehry made life very difficult. And if you are in Sydney, it's just off Harris Street. It's an amazing building to go and see. So what is building information modelling, or BIM? So really, people talk about whole of life, and that's the diagram that you'll see right there, and it's really from, it's either a green or brownfield site, so it can start from the renovation, programming, conceptual design, all the way through to construction and operation and maintenance. It's a process. It's not a piece of software. It's definitely something which people get a little bit confused about. So it is the process, and it begins with the creation of an intelligent 3D model. It actually begins a little bit before that, and that is around the detailed documentation or the design specification that you need to put in that model, and enables document management, coordination, simulation, which I'll talk about, fabrication, construction, and maintenance. And it is, again, for the entire life cycle of the project. So what is BIM used for? BIM is used to design and document. Every detail of the building is modelled in BIM, and I'll go into further detail a bit later on. It can be used for design analysis, creating visualization that helps stakeholders. So a lot of people that we were designing hospitals for who can't really see in 3D, see in 3D, so using 2D plans didn't really work. So we had to build mock-ups digitally of, say, an operating theatre. And then we use virtual reality to walk around that operating theatre, just for the doctors and nurses to get a feel of what that room would feel like. So it's really used for stakeholder buy-in. Cost planning, which is very important, and construction sequencing. The model is used to generate the design and documentation for construction, which means that it's accurate. So if something gets changed within the model, it gets changed in all parts of the document as well. So what is the process of BIM? So it supports the creation of intelligent data that can be used from start to finish. So we break it down into just 4 phases. That's plan, design, build, and operate. And I'll go through each one of these phases now. So the planning stage. So it's an informed project planning by combining reality capture or laser scanning, real-world data to generate contextual models of the existing build and natural environment. So this is a project that we did. This is in Melbourne. It's the Holmes Glen Hospital. Sorry, it's a hospital that was a Holmes Glen TAFE. It was used to train people in the hospitality industry, and the builder decided to turn it into a private hospital. So after we gutted the whole hotel that was part of the hospitality training, we then laser scanned it and then had someone draw in everything in a 3D model. So that was important because everything was getting refitted, so windows, doors, and all the interior as well. So it was very important that we had accurate dimensions for the openings, especially for the doors and windows. So on that note as well, there are a couple of projects now starting to appear that are only issuing 3D laser scan models for the tender phase. So you aren't able to do a site walk. You have to use a laser scan model provided, and then you can take your measurements from that, especially in some of the retro builds. I think 120 Collins Street in Melbourne is a prime example of where the property managers are doing that at the moment. So the design phase. So during the phase, conceptual design, analysis, and detailed documentation begin. And the pre-construction process also begins using BIM data to inform scheduling and logistics. So it's not only scheduling and logistics, but as I mentioned before, I worked on Margaret Court Arena. It was quite a complex project. It was taking existing outdoor tennis arena at the tennis complex in Melbourne and putting a roof on it. Sounded quite easy, but the Australian Open had to continue while that was happening, and it was a live construction site. And we started off with laser scanning all of the areas that we could, and then from there the designers built a accurate 3D model, including the steel. Now, unfortunately, the steel that the design engineers created didn't factor in secondary steel support, and being in the mechanical trade, we had to support very large fans and ductwork that were circling the perimeter of the stadium. So we had to go in and put all of our weights inside of the services, and then we had to design the secondary steel supporting as well. And that went back to the structural engineer, and they ran it through their structural engineering program, and then fed back that information, telling us whether or not we needed to add more supports or not. That was where BIM was used practically in the design phase, with input from the mechanical contractor or the fabricator to ensure that everything was being factored in. It would have been quite hard to go back and retrofit the secondary steel without first checking it in the model. The build phase, so quite an important phase, is where the fabrication not only begins and the construction also in the installation, but it's the logistics that the trades and the contractors need to use to coordinate and make sure that everything arrives just in time. So as you can see, BIM models are getting quite complicated. This is a University of Queensland oral health project. It's the largest private dental hospital in the Southern Hemisphere, and it has a lot of services. Even though it's quite a high ceiling void, they had quite a lot of complex services. So we modelled everything, including hangers and support bracing, and then we extracted that information from the model and then put it into a robotic total station, and that fires a laser beam, or in Queensland it was too bright to fire the laser beam, so then we had a staff and it would point us where the actual point was for the supporting rod. Would then precast or put it was called a blue banger, precast a thread in the formwork. The concrete would be poured, the form taken away, and we would have our thread in the exact location that the duct would be needed. And then from there, we took the model, and in the installation process, the people on site were able to look at the model in I guess, an augmented reality sense, and see what services were being installed. So this is another project in Melbourne, Craigieburn Town Centre. You can see that the marking out of the equipment is on the floor, and what we need to do is then put the equipment in place and raise it up using the model to make sure we have the right heights, and also there are no services. So this is a construction sequence. This was done in 2012 for the BHP redevelopment project. It was BHP head office needed to refurb their offices, and they put their mechanical plant room, took it from the roof down to the basement, all their services. And this is just to show, if you put timing and lead times and dates of installation in your model, you can actually do a sequence to show how that will be installed. What it did, it is identified that traditional installation sequencing wasn't going to work, and we had to get in early and put in all of the large ductwork at high level, followed by, strangely enough, equipment next in. And then from there, we went down and we sequenced into the next layer of equipment. And then what it also did is that because everything was sequential and linked, if there was a delay in something, we weren't able to install the next item in the sequence. The software was smart enough to resequence that so that minimal time was lost. This is 6 months in 90 seconds. And the contractor estimated it saved about 3 weeks in installation because they were able to identify the best way to install this plant room. And it included all services as well, including louvers, openings in walls, mechanical, electrical, plumbing, fire, siphonics as well. So the operation phase is equally as important, especially if you're connecting to a building management system, because that BIM data, it not only carries the construction material or information, but it also carries in it the commissioned or the as-built information as well, which is also quite important and can differ from the design intent information. So if we look at V6, the information inside of V6 is quite powerful. It not only gives you the type of material, but the cutting length, but it also tells you what other materials such as glass are used, what type, what seals, everything like that, which means that if there is a failure or a replacement that needs to be done post installation, then that information can be kept in the model, in the federated model, for then the facilities management and maintenance team to go in and actually identify what type of glass that was. I need to replace it, and I can order it as well. And speaking of that federated model, if you see now in V6, we have an export to IFC, and I'll talk a little bit about that later. So another image here that is through the BIM vision, which was done through the export to IFC, is something also more important for the installation and construction process is weight. Weight can be something that is overlooked quite a lot, and also it can be either under or overestimated. So here, because everything is modeled in V6 accurately with correct information, you're able to extract exactly what or how much that panel will weigh, and then you can adjust the installation process accordingly. So why is BIM important? So according to the United Nations, by 2050, the world's population will be 10 billion. So the AEC industry is responsible for delivering the social and economic spaces for the global population increase. It's fair to say we're not going to be able to just build or develop land at the current rate. We're going to have to look at refurbishment as well, which is quite important for the fenestration industry. If we're going to be refurbishing, we need to make sure that everything we create is going to fit back into where it should be. Also, by helping and maintain and restore the buildings and infrastructure, we must look for smarter, more efficient ways to design and build, which is quite important because with the 6-star energy rating and increases in decreases in carbon footprint, we need to make sure that we're doing things faster and smarter and become more resilient. So industry expectations now and in the future. So you may be receiving some requests from architects, especially to hand over a BIM model, and that may either you might not think is possible, or you may not know how to do that. And really what they're asking is they want some accurate data within your models to hand to them, which really include material, weight, cost, and then potentially the make and model. They want it in a common file format, Usually they may ask for a Revit file, but more commonly used is an IFC, Industry Foundation class. They want fabrication information early in the design. Now, that can be quite difficult, but really by using V6 and being able to give a high-level information back to the architect early on, I think they would be able to get more of an understanding of the weight, cost, and potentially the material that they need to use. And then operation and maintenance data. So this comes later on, so that's servicing, your warranty period, installed by, and last service by. So that is going into your facilities management and building management systems. They'll be needing that to plug in there, so then they can build an accurate maintenance schedule or actually a replacement schedule. So finally, this comment really rings quite close to my heart. Is not the strongest of the species to survive, nor is it the most intelligent, but it's one that's most responsive to change. And that's what really we've seen and seeing in the architectural engineering and construction industry is quite a rapid change and increasing demands on industry professionals to react accordingly. And it's just a case of how do we do that? And this presentation really didn't answer that question, but certainly should be getting you thinking about how will I start to respond to some of these questions and how can I change my business to prepare for those increases in requests and change. So thank you very much. We've got roughly 10 minutes for any questions. And by the way, if you have any questions or would like to discuss anything you've seen in today's webinar offline, you can contact me on brett.perez@softdeck.com. Also, if you do receive any questions from people that you're working for or architects and you're not quite sure, you don't understand what they mean, by all means, please send me an email and I will just and respond to that and help you as best as I can. So here I've got a question. Will V6 be able to export Revit or ArchiCAD format, not just IFC? I'd say that right now, I'm not the best person to answer that question, but I would say from an industry perspective, it wouldn't be good to export directly to native file format to Revit or ArchiCAD. IFC is the best way to export because a lot of the times the models from non-native software are going into a product called Navisworks, which reads a lot of file formats, and IFC tends to be the most reliable in exporting all of the data that they need. So exporting to Revit or ArchiCAD certainly would have its challenges, mainly because they're not backwards compatible programs. And what I mean by that, if you start a project in, say, Revit 2019, and then I can't then open that project in any other version. Earlier versions, I can't open the project at all. Later versions, I have to upgrade that project, and that tends to run the risk of losing information. So IFC is the most reliable form of export, which I believe that answers the next question, which is what is the best file type to send if an IFC, if a Revit file, or sorry, if BIM has been requested, and that again is IFC. And then another question that came in is, do I need to worry about having too much information in my files? And the answer to that is no. Usually exporting information is quite small. The metadata is quite small, and programs used to create the federated model are able to manage and have a good compression file format, so they are able to manage large files. I've been in a project that has combined federated models of over a terabyte it was, and that included laser scanning all the design information and about 400 models. So you don't need to worry about that. What I see the industry moving towards is more interoperability and connectivity instead of this static process of exporting a file and sending it. using connectivity to actually tap back into the original authoring software would be a better way of doing things. So having almost like a live link, or freezing a model in time and storing it somewhere, and then having the construction team or the project team access that model. So then instead of having the export and then import process, which is quite lengthy and arduous, and it is quite static. So there are no more questions. Alison?
Right, so I think that brings us to the end of our webinar. Again, like Brett said, if you have any questions or any concerns or any information that you'd like to find out more about BIM or building information modelling, Brett's the person to get in touch with. His email address is on screen. A copy of the webinar recording will also be emailed to you after the event. And again, get in touch with either Brett or myself if you have any issues or concerns with that. And thanks again for joining us. Thanks, Brett.
Thanks, Alison. Thank you.